Question number 1. Work has same dimensions as. There are 5 answers: energy, force, momentum, power and impulse. We know that work has dimensions of energy. Work and energy has same dimensions. Therefore, answer for the question number 1 is 1, energy. We know that dimensions of energy ml squared t minus 2. And for the second answer, force is dimensions of force ml t minus 2. Then third answer, momentum. We know that momentum is mass into velocity. Therefore, dimensions ml t minus 2. Fourth one, power. Power means energy, rate of energy. Rate of energy is energy divided by time, or work done divided by time. ml squared t minus 2 divided by t. Therefore, dimensions of power ml squared t minus 3. Then last one, impulse. We have to remember that impulse is a change of momentum. For a collision, we are defining impulse. Impulse is change of momentum. Therefore, same dimensions as momentum, ml t minus 2. I have described all dimensions, but answer is work done and energy should be with same dimensions. Then question number 2. The light year is equivalent to. The velocity is given, velocity of light is given 3 into 10 to the power 8 meters per second. Light years is a unit we can use to measure a length. We are measuring distance between stars by using light years. The meaning of definition of light year is the distance traveled by a light ray within an year. We know that speed equals distance over time. Speed equals distance over time. Therefore, we can subject distance, speed into time. Speed into time. Then we can multiply the speed of light by time for 1 year. The speed of light rays 3 into 10 to the power 8 meters per second. This is the distance per second. We have to multiply. It means velocity or speed. We can multiply by time. We know that there are 3,600 seconds per hour and 24 hours per day, and we have to multiply by 365 days per year. They have given answer in kilometers. This is in meters. Therefore, we have to divide it by 10 to the power 3. When dividing 10 to the power 3, we can write 3.6 into 24 into 365. This is the answer in kilometers. Then we can get answer is 2 for the question number 2. Then question number 3. Which of the following quantities is calculated by multiplying force by time? Force into time. We know that according to Newton's second law, force equals to change of momentum divided by time. According to Newton's second law, the rate of change of linear momentum equals to force. Then force multiplied by time. Force multiplied by time is change of momentum. Change of momentum is a momentum. Therefore, we can get momentum by multiplying force and time. Therefore, answer is 2 for the question number 3. In question number 4, the distance is traveled by the vehicle during t time is given by the equation s equals at squared into 1 plus half bt. The dimensions A and B are respectively. We can find dimensions of A and B. First of all, we can remove this bracket by multiplying terms within the bracket by this one. AT squared into 1 AT squared plus AT squared into half BT half A B T cube. They have given capital T and simple T, but both values should be timed. I think that it is a printing mistake for this book. Then we can get, there are three terms in the equation. If this equation is dimensionally correct, all three terms should have same dimensions. Then we can get dimension of S should be equals to dimension of AT squared. S is distance, we can write it L. We have to find dimension of A T squared. Then bring T squared to the left hand side, LT minus 2. It is the dimensions of A. Then we can consider this term and this term to find the dimension of B. I will consider dimension of S should be equal. Half is a constant value. There is no dimension. Therefore, ABT cube dimensions. S is a length. We know that A is LT minus 2. Dimensions of A, LT minus 2. We have to find dimensions of B, T to the power 3. We can cancel out T to the power minus 2 and T to the power 3. There is only one T term in right hand side, and we can cancel out A term. This T term should bring to the left hand side. Then T to the power minus 1 is dimensions of B. Then we can get answer 3 for the question number 4. Then question number 5. Which one of the following pair of contain one vector quantity and one scalar quantity? Vector quantity means there is a direction and magnitude. Scalar means there is only magnitude, there is no direction. In first answer, they have given displacement and acceleration. We know that both physical quantities are vectors. In second answer, power and speed. Power and speed are scalars, both are scalars. Then third answer, work and potential energy, both are scalars. Fourth one, force and kinetic energy. We know that force is a vector and kinetic energy is a scalar. Therefore, answer 4 for the question number 5. And when considering last answer, momentum and velocity, we know that momentum and velocity are vectors. There are directions. Then question number 6. Which of the following can be measured in joules? Question number 6. Part A. Work done by a force. We know that it is measured. It can measure by using joules. Then part B. Gravitational potential energy. It is an energy type. We can use joules to measure gravitational potential energy. Then third part C. Moment of a force. We know that moment of force is force into perpendicular distance. We can use Newton meter, but we can't use joules for the measurement momentum or moment of force. But we can use Newton meter and joule for these two quantities, Newton meters and joules. But we can only use only Newton meter for moment of a force. Then answer A and B only correct. Answer 2 for the question number 6. Then question number 7. Consider the following quantities used in physics. Which of the above is a base quantity or quantities of international system of unit SI system? We know that there are 7 base quantities, fundamental quantities in SI system, mass, length, time, amount of matter, current, electricity, Kelvin temperature or absolute temperature. Seventh one is light intensity. But they have given in part A electric charge. It is not a base quantity. A is incorrect. Then B, mass. Mass is a fundamental quantity, base quantity, we can consider it. And third one, C, temperature also fundamental quantity. Then B and C only. Answer 4 for the question number 7. Question number 8. Which one of following is unit of momentum? We know that momentum is mass into velocity. Mass into velocity. We are measuring mass by kilograms, velocity meters per second. It is the unit for momentum. But in these answers, they have given Newton. We know that Newton is kilogram meters per square second. MA, mass into acceleration. Then we can use Newton. If we are using Newton for this answer, there is only kg ms minus 1 for momentum. In this term, kg ms minus 2. There is is minus 1 term in this unit. Then we can consider kg ms minus 1. We can convert minus 2 to convert to minus 2 s2 by multiplying numerator and denominator by s minus 1 without changing the unit. Now we know that this is Newton, then Newton divided by per second, it means Newton second. We can get answer 3 for the question number 8, or we can use any other method. Like we know that force is change of momentum divided by time, then we can get force into time is change of momentum. It means unit of momentum is unit of force into unit of time, Newton into seconds. Question number 9. If A, B and T, it should be T, in the following equation represent force, acceleration, velocity and time respectively. The ratio is C1 over C2. I will write the equation F equals C1A plus C2 B over T. We can get there are same dimensions for all three terms if the given equation is dimensionally correct. Then we can write dimensions of force mLT minus 2 should be equal dimensions of C multiplied by they have given A is an acceleration, dimensions of acceleration LT minus 2. Then we can cancel out LT minus 2. Dimensions of C1, dimensions of C1 should be M, mass. And same method we can use force, dimensions of force should be equals to dimensions of this part. Then I will consider dimensions of force mLT minus 2 should be equals to C2 dimensions multiplied by V is velocity LT minus 1 divided by T. We can cancel out one L term, T minus 2 with this T term. We know that this T term is T minus 1 when being to the numerator. We can cancel out. Then dimensions of C2 also M, there are same dimensions. Then ratio of C1 and C2 has no dimension. Then we can get answer is dimensionless. Answer 5 for the question number 9. Question number 10. One of the following quantities measures a physical quantity that is different from the physical quantities measured by the other. This is part 1, electron volt. We know that electron volt is a unit of energy. We are defining electron volts as the kinetic energy obtained by an electron when it is accelerated within 1 volt. Then it is energy. Joules per second is not energy, J is minus 1. It is a power, joules divided by time. Third one, watt second. Watt is power multiplied by time. Power into time is work done. Third answer also energy. Fourth one, kilowatt hours. We know that energy consumption in house is measured by kilowatt hours, electricity unit. It is a unit of energy. Then fifth one, it is given with the prefix electron volt, mega electron volt. Mega electron volts also a unit of energy. Therefore, we can't use second answer for measuring energy. Then answer is 2 for the question number 10.